the commands it gets from the mainframe. Second, security considerations. We have all this protocol stuff has a purpose, and the purpose is we want to control we want to do a flux control through the protocol structure. This means we want to control, and we want to control the clients, and we want to say, hey, okay, we don't want any more clients in our framework, so we do not issue any further nonces. And if you say, okay, our clients now they should just rest and do nothing, we just block existing clients from distributing by increasing, for instance, the next update time. So each extension will wait a very long time, or we just stop issuing next tickets. So if you don't get a new ticket, you don't get a new phony token set, and so the extension will not attack. Of course, it's a problem with the single point of failure. All the potential or all the real phishing pages are stored on the server side. So if you own the server, you get a botnet for free. I said at the beginning that it's possible, that it's also possible to analyze and to track the phisher. Yes, I think this is possible because we invented something called a phonypot. This means a phonypot, it simulates, for instance, an online banking web application. So the phonypot distinguishes between valid user credentials or valid users which want to do their online banking business, and phishers who enter with a phony token. So if you as a phisher want to check your phished accounts, sooner or later you have to check one of the phony tokens, and you say, okay, now let's check this, and this set of credentials. You go to the online banking application, and the application will recognize, okay, this is the phony token, so we will send this guy not to the real online banking application, but to the phonypot. And the phisher, he will not recognize that because it perfectly simulates, the phonypot perfectly simulates the attack service. We have 4 requirements for the phonypot. First of all, it's very important that the phisher cannot distinguish between the phonypot and the real banking application. It all looks the same. So the second requirement is breakdown in passiveness and isolation. This means it should not be possible if you are on the phonypot, if you are redirected to the phonypot, it should not be possible that you interact with the real online banking application. Of course, all the traces you leave at the phonypot should be recorded, and you can make a risk analysis through scoring. We call this phishiness. I mean, measuring the evil. It's phishiness is the probability that a connected client is a phisher, and then, yeah, you can put them in 3 different levels. You can say, okay, this is a definite phisher because he uses a phony token. If someone comes to my online to my online banking application and tries to log in with a phony token, then this must be a phisher. So we can say, okay, this is definitely a phisher. We can redirect him to the phonypot. The second stage is, or the second level is a potential phisher. All right, this client uses, for instance, an IP address which has been used by a definite phisher, for instance, 30 minutes ago, something like this. So we have, we cannot say it's a definite one or it's definitely a non-phisher. We just say, okay, we will analyze this client further. So yes, and the third level is the definite, or the non-phisher. This is a normal client which tries to log in with his own credentials in order to do the online business. So you can use for calculating the phishiness, you can use other ISO-OSI layers. For instance, you can use the IP address, you can use some TCP fields, you can use the user agent, you can use the login, etc., etc. And after that, you can compute a value, and this value we call the fishiness. So, limitations and problems. This framework only works for the old school phishing attacks. Today, phishing attacks work pretty much in another way. They use, the bad guys, they often use, they now use malware, and malware has different transmission protocols, or can have different transmission protocols, not only HTTP, but IRC or peer-to-peer, etc. And what we need is old school phishing attack. I mean, you get an email, you have a malicious link, you click on this link, and you think, yes, that's my bank. This is old school. So we can only attack old school phishing attacks. So another problem is that we already talked to several big financial institutions and banks and discussed this framework with them, if they want to use it or not. Currently, we don't have a carrier organization found. So I think this is still a problem, and if we cannot find any carrier organization, this project will die. So, and another point is, of course, do you really think this works in practice? I mean, what we have here, we have a theoretical approach, and we have a proof of concept, which works in a laboratory environment, but how does this work in the wild? Can we make sure that only obvious phishing pages get analyzed? I mean, it's, as I already said, you have the problem with the single point of failure. What happens if the administrator of the mainframe is drunk and he puts some real banking websites in these phishing databases? Yeah. Another point is, do we have a fallback PKI? I mean, what happens if the certificates change? So no extension can connect anymore. And do we have an answer to the question of legality? A lot of institutions we talked to and who were interested in this framework, they said, okay, is it legal? Can we use it? What about the FishPhucker extension? Is it legal? These are all questions I don't know any answer. So anyway, I think it wasn't so boring. Thanks for listening. You can visit this webpage if you need any more information, like the technical paper, etc., or just drop me an email. Thanks.
All right, thanks for the talk. If you have any questions, I'll go around the microphone and just raise your hand. Oh, first one.
So not only do you need a carrier organization, not only do you need one carrier organization, you need all of the possible phished sites to cooperate with you that use SSL, so that you can go to their pages and they'll accept your tokens.
I don't get you, sorry.
So let me see if I understand. When the fish tokens are to be used, they're used at the actual financial institution site, correct?
Yes, yeah.
And they recognize that it's a fish token, and then you can harvest the actions. So you need the cooperation of Deutsche Bank,